Hi everyone, and welcome to episode 27 of the Sustainable Builders Yak podcast, a podcast that gives you the confidence to build high-performing sustainable homes. We'd first like to begin by acknowledging the traditional owners of the land on which we meet today and pay our respects to elders past, present, and emerging. Now, don't forget to check out the website, folks, on thesba.com.au. We're constantly sending out fantastic information across Instabox and FaceTube. And Hamish he's just finished an incredible webinar this week on how to ace Passive House. I was on there myself with two of the gurus of Passive House. It's an absolute cracker. So I'll run back and have a listen to that one. And if you like what you hear on the podcast and you want to hear more, please hit us up at hello@thesba.com.au. Give us some content so that we can get some more information out to you. Okay. Now, today's podcast is sponsored by Rylock Windows as our founding sponsor, and our gold sponsors today are Performance Membranes and Purcell Homes. And as always, thank you all for your continued support. Without it, we can't do what we do. As always, I'm joined by my co-host, Simon Clark from Sustainable Homes Melbourne. Good day, Simon. How are you?
I'm good, Brian.
You guys are doing all right over there?
I'm going all right. Yes, ready to get my hands dirty on this one.
So you're over the Christmas now. We're back into a new year.
Yeah, well, it's a distant memory now.
Yeah, I just wanted to cool down a bit. We are getting absolutely cooked in WA. I just needed to get below.
Yesterday.
Yeah?
38 yesterday, 19 today. That's the way Melbourne rolls.
Wow, man. No, we've been constant, like 38 to 41, 42. We had one day here where it was 45 up in RAF Air Force Base. It was just too hot, man. It's ridiculous. Guys are going home from work, you know?
Oh, yeah.
Yeah. But anyway, it's better the sun shining than the rain pouring, I guess. We need both. Now, today, folks, we have a guest on to discuss a product that we've mentioned many times in the past over several different podcasts. It's come up quite a bit. We were joined today by David Singh, who is the State Manager for Surefoot WA. Welcome, David, and thank you for joining us.
Yeah, thanks for having me, guys. We're looking forward to seeing what we can talk about.
Yeah, we are as well. This is like I said, it's come up quite a bit, and we've had quite a bit of discussion over the internet on it. A lot of people asking questions about what is this? Why do you keep talking about it? So here it is, guys. Now, David started in the construction industry about 35 years ago as a plasterer, and then he's been involved heavily in commercial construction for about 20 years in various capacities, from site supervision, contracts admin, and currently he also imports some structural steel and double glazing. He is, as I said, the State Manager for Surefoot. Now, Surefoot specialises in micropile installation, providing a reliable and efficient solution for projects with challenging soil conditions or limited access. Also known as micropiles or mini piles, batter piles, small diameter piles that offer exceptional load-bearing capacity in tight spaces. So this, for me, this is I think this is a very innovative and groundbreaking product. I really, really do. I think this is one of these things that will change the industry for the better with respect to pre-manufactured construction. I really think this is an option that will open minds. And that's what at Builders Yak, that's what we do. We try and open minds here. So look, David, let's start off with a little bit about your past, man, where you grew up, how you got to where you are today, and how you ended up at Surefoot.
Okay, well, born in London, came to WA as a child, lived at Fairbridge Farm School in Pinjarra. A few West Australians know about that place.
Oh, you're a bit of a music buff then, are you?
Sorry?
A bit of a music buff?
No, I lived there when it was a farm school, a boarding school.
Oh, right. So the reason I said that was Fairbridge has a really, really good music festival every year.
Yes.
Very, very good music festival.
If you define that music as really good, I'll challenge that one.
Come on, there's all kinds of genres down there. It's a ripper. It's a good camping week, so it is very, very good.
But then moved to Perth, finished my primary school and lived around basically Glendalough, grew up in Loo, and then got into trouble in Scarborough in my teens and carried on from there.
Rightio. So how long were you locked up for?
No, I never got caught.
So you said you were in the commercial industry. How did that come about? As you started out as a plasterer and then ventured in, as one does, into the commercial industry.
Well, look, from being a plasterer, I got involved in roller shutters earlier on, window roller shutters. I saw them as a sort of opportunity. I've always followed my nose with innovative things. I got involved with ICF, insulated concrete formwork.
Yes.
A fantastic construction method as well.
Yep.
And then eventually ended up in the commercial game and just followed my lead from there. It got to the point where that was sort of Not so much. I was doing a lot of the similar things. Once you're in the game, a lot of buildings are the same. And that's when I got involved in importing steel and windows, because I saw that people were importing anything and rubbish without looking at the detail and the quality of what they were bringing in.
Yeah, there's a lot of that, particularly in WA. I noticed that as well. A lot of that.
And
Yeah.
a lot of that is to do with the fact that large builders go to China and they buy the cheapest crap they can buy because it fits their model. And but unfortunately, 2 or 3 years in, our sun tears the glazing rubbers apart, and then they shrink, and then the builder's no longer responsible. But that's when they're the issues that you can have down the track. So there's not enough quality control in the industry, I think, in general. From I suppose it's right across the board, but in windows in particular, I see things where I got just cheap craps brought in.
Maybe we should forget about Surefoot today and just go on Windows. What do you reckon?
Sorry, I digress.
Because I would love to do that. Look, folks, anyone out there,
Next
we're working on a Windows one.
Okay,
there's one coming. There's one coming. Absolutely.
Sorry, boys. Sorry.
So,
that's all right, mate. We've got 10 people chomping at the bit for that one.
I'm keen to just touch on you guys in Perth being, what is it, the most isolated capital city in the world.
Yep.
You get pretty accustomed to importing or getting things from a distance, wouldn't you?
Yeah. It's quite common. The quality is the issue. So if you don't have the knowledge of the product and you're just basing it on price, it's exactly as David says, especially on large scale projects. They need a product, they need it for a certain price, they get it to site, they put it in, it services, it ticks the boxes, let's just say. And this is just me talking off the cuff. This is not every builder. But when you get to large scale developments, they have to, unless there's a really good architect involved who specifies a specific product that they know works. If that's not the case, and it goes, through the design phase, and then it's taken over by the developer, and the developer essentially can do what they need to make the project work, you do tend to see some bad product coming in. Absolutely. And if the knowledge is not there, and the liability or the accountability, let's just call it, is not there, then it's exactly as David says. There's some really bad products there, and unfortunately, the people that own the building own the issue.
And also the issue in the industry is the experience is not there of people who know what is there and what it should be. But there's not the experienced people in the industry to know what is and what is not correct for the job type thing. Since apprenticeships finished and got reduced, I think that's really, the industry has got to the point now where there's no. I'm on building sites a lot. I'm amazed how many blokes that are like me in their late 50s on site still doing the work.
Because they have the experience. And they are sought after. I think, at the risk of getting in trouble again, as I always do, I think we're very fortunate with our climate in Perth. If we had freeze thaw here of any kind, or if we had more rain than what we have high rainfall, but it's intense rainfall. So it's for a short period of time. It's very heavy, very intense, and then it stops. So we don't have prolonged rainfall as such. That is changing. We're getting wetter winters, but I think that's a bit of a saving grace here in Perth. If we had Melbourne weather, a lot of these buildings would be in a lot of trouble, in my personal opinion. Anyway, back to Surefoot.
Yes, mate.
Right. Look, as I said, it's come up in the podcast a few times in the past. It seems as though it's something that people are looking more and more at in the industry. So let's start off with the basics. I'd like to know where it came from, firstly, and then I guess how did it get to where it is today? Because it's a bit of a juggernaut story, to be honest. It's in New Zealand. It's in a lot of countries in Europe already, where we see it popping up all over the place. So where did it come from? Who's the guy? There has to be a guy. Who is he?
Okay, the guy credited with taking Surefoot to where it is today is a gentleman by the name of Neil Despotellis. He's a Victorian fella. The product was invented 20 years ago or so by Neil and others, I believe. And I think the concept had previously been around, but what Neil did is he took it to Swinburne University, to Melbourne University, and then perfected it effectively, rather than being a flat plate with sleeves that pins itself to the ground. The university came up with the curved design and the skirts on the side, and that increased its strength exponentially, and also its ability to take moment load and things like that. So Neil took it from a basic product that would do the job to a product that can be engineered and guaranteed to do the job, because Surefoot took the time to do the research with the universities and come up with a great solution from my perspective and many others.
Okay. So can you take a second now to explain to us what load capacities we're talking about? So there's I'm not going to go through all the different types of piles, but there's the basics, and then there's the really heavy duty ones. But let's just start at the basics, and we're talking like, you know, the T150s or the S150Ws, stuff like that. Let's talk about load capacities. What are we talking about here? Can you explain that to the audience?
Radio. Well, I'll talk about our the most commonly used one is our S250 4-way.
Yep.
Now, that is a footing that'll take a bearing load of 10 ton and 5 ton in uplift to pull it out of the ground. Now, to achieve those figures, to give you an example, if you were driving into clay, you could achieve those figures by driving your mini pile in about 1700, and that'd be enough to achieve your 10 ton and 5 ton uplift. If you were driving it into sand, you would then go to a 2 meter pile and drive it in further to achieve the same. So we use geotech information a lot. So the ground condition really does determine the footing that we use, and along with the pile depth.
Okay. So for the layman out there, on your website, when you look at your website, you refer to kilonewtons all the time. Can you explain the difference between what you just said? So you said tons of uplift and bearing capacity. So bearing capacity is loading of a building onto the pile, and uplift is pull from a building that's trying to pull out of the ground. Let's say if you have a tornado or whatever.
Okay, yeah. So just let me just clarify from a footings perspective, is that where you build a double brick house on a slab, a Surefoot footing is not sort of applying in that application. But if it's a prefabbed house and a house on stumps and what have you, that's really where we come into play more.
Yeah, absolutely. So it is to do with raised floors, and particularly floor cassettes, etc. It doesn't work. Well, I wouldn't say it doesn't work. You could, if you really tried, you could put steel on top of them and then build brick, but we're not going to go there. But just explain, like, on one particular micropile, which you just said, which is the S250 4P. The 4 stands for 4 piles.
Four-way. So there's 4 piles, and they drive in four directional piles.
Yeah.
So it's the display of those piles that does the job, but the skin friction of those piles being driven into the ground also does the large part of the heavy lifting when it comes to the uplift and the bearing load of the footing itself.
Yeah, so they're nicknamed the tree root.
Correct.
Yeah.
And that 4 pile, that'd be your smallest, is it?
Yeah. Well, that's there are
system.
smaller ones. The T150 that Brian mentioned earlier is the one that you would use if you were building a deck and you just wanted to run some bearers on the ground, and it's easy to put in. The S150 is another small mini pile that you could probably drive if you were building a deck and wanted to drive them in with a sledgehammer. That's an easy thing to do rather than dig a hole and pour concrete. But then you go right up to our largest S600, that'll take a load or a weight of 36 ton. And by the way, to answer your earlier question, Brian, 100 kilonewtons is a 10 ton, 10 newtons per ton. And the S600, we have put 18 meter communication towers on those, so they really do a lot of heavy lifting.
I've
one
seen
of them, or
them.
how many?
On a single unit.
A single one. So this 4 pile system, is that equivalent, let's say, to a standard concrete stump? Yeah, relatively.
So
variables.
Yeah, I always equate that 10 ton to a cubic meter of concrete.
Yeah.
Cubic meter.
So
of
the
concrete.
same bearing capacity and uplift
Yeah.
as a cubic meter of concrete. So
Yeah.
that's a lot, because
So
generally
it takes
you're
a
not
lot
putting in-
more than just the one
Yeah.
stump.
Yeah,
isn't it?
yeah. I've seen it where we've done projects where they've come to us with concrete engineering, where the engineering has required a 600 by 1500 deep pier, concrete pier that we've replaced with just an S254 way and 1600 millimeter piles from memory.
Jeez.
Okay.
So that's yeah, and when the projects get larger, and if the buildings are designed with the Surefoot capacity in mind, then you really have a big win. I'll give you an example. Is WA has a lot of prefabricated buildings. They're all 4.4 meters long by 3.5 meters wide, I think, for transport on the roads and all over the place. Now, the majority of them are built on 250 UB chassis rails. Because those chassis rails just do carry all the load for that building, we can put down, in many cases, 6 footings to anchor that whole building to the ground, 6 S254 ways. So because you remember that's 60 ton in bearing load and 30 ton in uplift for a building that probably weighs 3 to 5 ton. So those 6 footings will do all of that work. And when we go to region D cyclonic regions, we can do it with 8 footings. And they may have a 6 pile rather than a 4 pile. So depending once again on what the ground is like, if it's soft Pindan type soil, then they're going to want a bit more depth in the soil, because when the rain comes, the top of Pindan turns to clay. So they know they want to be anchored very deeply in the ground. But if you're in the Newman area where it's hard, dense, rocky ground, you can drive them in 1500 and job done.
So just to simplify that, what's that sort of size of house? Is that a 100 square meter house, a 200 square meter house? What's that?
No, this is a prefab building that they're like a transportable building that they used a lot in the northwest of Western Australia to build as like two of them together is probably an 80 to 100 square meter house. They join them together.
And
Yeah.
six, and only 6 of those
Piles.
Surefoot piles each.
So you would
Yeah,
have 12 piles under a house, essentially, Simon.
Yeah.
But that's
Keep
not the
going.
best part of it. The best part of that is when you go to regional, you don't need a concrete truck. You don't need an excavator.
Yeah.
You just need a ute with this stuff on the back of it and a jackhammer, and a guy that's got a pair of muscles to drive it. It's that for me is the key. So when I say when it's a perfect fit for modular construction, because the whole idea for modular construction is to eliminate trades, to eliminate the requirement to bring additional trades and materials to a remote location. This absolutely fits the mold. It's incredible.
Our last guest, Alejandro.
Oh yeah.
I hope I'm saying it right. That's what they use, and
Yeah.
Yeah. It's
So David, you'll recall a project you did down in North Fremantle. It's called the My Home project for Highbury Homes.
Yes, I do.
Yeah. So we actually spec that along with the architect. So I was involved in the very early consultation of feasibility studies for the project. And when we were doing the feasibility studies, one of the challenges with that particular project was that it's a specific lease. So because it's accommodation for the homeless, it's only a certain period lease. So it's a shorter lease, right? So we have to take the site, build on it, put these people in homes for 20 years, then take it away and leave the site exactly as we got it, right? And when we were looking at all the systems and processes, we kept coming back to, you know what, if you put concrete down, well, it kind of is what it is. You got to pull the plumbing and stuff out anyway. But when we were talking to offsite for the pre-manufactured portion of it, it's like, well, it's floor cassettes, wall cassettes, roof cassettes. That's what we're going to do because that's how it works. That's the best way to do this, because you can take the whole house, flat pack it like IKEA, put it on the truck, bring it, put it together, then take it apart, put it on the truck and take it to the next place if you need to, right? So to satisfy that portion of the requirement, we ended up on Surefoot, and nothing could even come close when it came to Surefoot, because you can literally pull these things out of the ground the same as you put them in. It's just incredible. that was when I discovered it first. It's probably 5 years ago when we started the feasibility on that project. And for that particular purpose alone, just the fact that you can put it on a site, it does what it needs to do with minimal impact on the site, and then you can actually remove it and have less impact on the site. I think that's where it's going to really, as short stay accommodation in regional areas, exactly as you pointed out, underneath modular construction in mine sites everywhere. If you don't have to have concrete trucks, that's an absolute win.
Well, I'll tell you where really we're having big wins at the moment is solar farms. Because
yes.
remote area solar farms, to get concrete out there is a real difficulty. But not only that, with concrete, you, especially with larger projects, you have the curing time to deal with. And that creates a double visit to a site. So you mentioned earlier with your 12 footings under a modular building, we can go to site and we can have that done inside of a day. The next day you drop your building on. There's no waiting for curing. And the other part of the real important part that our customers or our feedback that we're getting is the fact that we install our footings plus minus 2 to 3 mil. So when the guys roll up with the buildings to land them, they just land them straight on the footings, job done, no shims, no packers, no trying to leveling this corner or pack that corner. Or because of the way we work, we can leave everything, as I said, plus minus 2 to 3 mil, and the building just gets dropped on, job done. And then we have a clamp system that clamps the flange of the UB. Or if you're a welder, you can simply weld the UB directly onto the Surefoot, job done as well. So that's I always say to people, it's one of the keep it simple, stupid principles. If you're going to drop a sea container or anything like that onto a Surefoot, then just weld it straight to it and it'll job done. No bolts, no messing around.
So you've gone into one of my later questions, but I want to go backtrack a little bit. I want to see, so folks out there, you need to jump on the website, please, surefootfootings.com.au, and have a look at these. Essentially, they're almost like a dinner plate turned upside down. It's a flat plate with turned edges, and then there's female short pipes welded to the externals at various angles. It's kind of hard to describe, but jump on the website and you'll see what we're talking about. It is revolutionary what it is. But let's talk for a second about the actual plates themselves and the pipes, right? So what is this made from? And then what kind of gauges of steel are we looking at? And then what's the ratings on them?
Okay, the Surefoot S250 is a 6 mil steel plate, heavily galvanized. The Surefoot itself has got a 650 grams per square meter of galvanizing, which is almost double what is probably standard. So that goes a long way to helping our 50-year design life, a minimum design life properties. And then the galvanized tube, once again, is a heavier galvanizing that Surefoot used to, once again, keep the minimum 50-year design life intact. And it is a 2.7 mil wall in the pile. It's a 32 nominal bore pipe. At certain projects, we'll use a medium pile where we'll go to a 3.2 mil wall if we need to if we're in a corrosive environment, for argument's sake. A thicker pile will last longer. That's how that.
So from the 150,
sorry, Brian,
go ahead.
Sorry, Brian. I've got to interrupt you. I think we've missed the magic. My eyes were watering when David's talking about he can apply these footings and get them within 2 to 3 mil. My memories go back to my chippy days, trying to bloody do concrete stumps, dropping them in, dropping them out with a bloody laser level, banging them down with a stick of timber. Good Lord.
Actually, Simon, the job that we were on that Brian mentioned down at North Fremantle there, those chippies came up to my boys and they thanked them greatly because literally they turned up to site, dropped all the beams on, and this was along a row of about 20 footings. Each run was probably 20 footings. And the chippies turned up, dropped the beams on, bolted them to our top bracket we had sitting there waiting for them level. And that was it. They're off and running. They had no leveling to do at all.
And then it was floor cassettes, just dropped straight down on the top. It is literally IKEA.
That's unbelievable.
Yeah, they loved it too. But actually, getting back to your previous point, Brian, I think about removing them after the job, after the site has to be cleared. The process there is effectively and we've just done it recently at a West Track site, where we dig down 100 millimeters or so.
Yep.
We'll cut through the pile with a resit saw, and then you can take off the Surefoot cap and reuse it.
Yep.
And then the piles themselves, you can either choke them with a sling or a chain and a large excavator.
Yeah, and just pull them out.
Pull them out, probably a 3 ton or better. It's still not an easy job, but you can do that way. Or you could just have a big excavator go through and just pretty much just dig them all out and bend them all up and then clear the site that way. But the main thing is you'd get to reuse all of those Surefoot again at the next job somewhere else.
Yeah, very, very good. So can I go back again? You said it was a 32 mil pile.
Yeah. Nominal bore.
Yeah, nominal bore. Yeah. So when you go from the T150 to the S600, same pile?
Yes.
Just more of them.
More of them. So the S600 has 16 piles. Yeah. So yeah, that's the difference.
Okay, so it's the same pile. And then when you get to the various site classifications, the only thing that changes is the depth, how far you drive it in.
Correct. Depth and size of pile. So, for example, we did a year or so ago, this is at the Gogerup Boardwalk down in Dawesville.
Yeah.
The fisheries put or CALM or whatever they're called, I can't remember. Department of
Conservation. Yeah.
Conservation and Land Management.
Yeah.
They wanted to put a camera up there so they could monitor dolphins in the estuary to make sure they didn't get trapped.
Yep.
So in the swampy ground, they put a camera on a 6 meter pole, 7 meter pole, but that went on an S400 12 pile, one of our larger footings. And the reason for that was not the weight or uplift, it was more about moment load.
Yeah,
because you've got a tall pole with a solar panel and a camera on top. So it needed the spread of the 12 piles to counter the moment load of that being battered on a windy night down in Dawesville.
So that was I don't know how to go into these questions, but there's a couple of a few alarm bells go off. Like what if your water table is very high? What if you're close to the ocean? What if there's salt in the ground with your water table being tidal? How is this like too complicated, or how do we go there?
It doesn't. Water fluctuation doesn't affect the performance of the Surefoot at all. Neither does expansion in clay and other forms. But what the water receding and coming back does do is it accelerates the corrosive activity.
Yeah.
So to counter that, once again, you would, if you were going into that environment, you would use maybe a medium wall pile, so that that the medium wall will take 50, 60, 70 years for it to rust through.
Yeah.
And generally those projects will have a 10, 15, 25-year design life anyway. And so in that application, that's covered. But in other applications, like, for example, we've provided footings for houses on Cocos Island. Yeah. They have to be stainless steel.
Yeah, that's what I was kind of getting at.
That's the only product that if you're going to build a house that you want to be there for 100 years, then stainless steel is the way to go.
Yeah.
Brings its own challenges, but then you've got it's double the cost, but you've got a product that lasts forever.
Is there an option to have the cap plates in stainless as well, or no? You haven't come across that yet.
Have the what? Sorry.
The top plates.
Yeah, we do them in stainless as well.
Okay.
Yeah.
So the reason I asked that is, in WA, right on the coast here.
Yeah,
it's an absolute option because there's a lot of projects that are on hills in particular, and those houses will be on stumps. And this is you can't get excavators in there. It's quite difficult. This is a really, really good product for that, especially being in sand. Okay, so I think you've hit two of my questions already with respect to site classifications, etc. So
Sorry, sorry, Brian.
Yep.
The site classification I'm most keen to hear about is rock.
Yep. Okay. Well,
How they go.
drilling into rock was a system developed by our guy in Northern Territory, Peter, where he used to put communication towers on the top of rocks all across the Northern Territory and Northern WA, and he used to fly the materials in with helicopters and drop it all off on site. And then obviously being a communication tower had to be on its highest point and up on a rock. So what he would do there is place the Surefoot on the ground and then effectively drill through the sleeves into the rock and grout threaded rod into place, and then place large structural square washers on top of that, and then double nut that down. So you'd be drilling into the rock, probably, depending on what's going on top, of course, anywhere between 250 if there was nothing above a couple of meters tall, to 450 if you were putting a sort of a 6-meter communication tower on there, like an aluminium lattice frame communication tower, so that it's got a certain amount of rigidity itself. Then you would just drill the holes through the sleeves, and everything we do is engineered. So we would have an engineer look at that project. The engineer would say, well, look, just put an S258 pile down, and I want 6 threaded rods in there, and then I'm happy with that at 250. And then so that's how an engineer would come up with a solution in that application.
What about a home in in a city? Is Surefoot a feasible option when the expectation is that, well, rock or basalt would be hit, whether they're floaters or?
Yeah, well, look, it's the same. If you were going to put concrete down, you'd be hit with the similar issues. Where if you've got a big rock there, you've got to get a big machine in there, and you've got to break that rock up. And that machine, they don't give you a quote; they charge at an hourly rate. And when the rock's broken, then they give you the bill, and you've got all those sort of open enders coming your way. So really, to use, if you know the site is maybe have a few rocks, but not everywhere, and a lot of places, depending on what the rock is, shale rock, we will blast through with our jackhammers, and coffee rock we'll blast through with our jackhammers, and we'll get our embedment. Granite stops us cold, and that's where we simply pull out the drill 250, 300 mil into that granite, and depending on where it is. It's in epoxy if it's in a region D, for example, cyclonic region, but we can get away with grout in other regions. So that, once again, that's always an engineer's call, because he's the one signing off on its longevity.
Yep.
Okay.
And you have your own engineers, or are you expected to?
No, well, look, there are our head office has its in-house engineers, but we actually contract out all of our engineering, and we use several engineers around Perth.
Yep.
It's pretty much across the board. Their convenience comes into it. We've done projects in Papua New Guinea where only certain engineers have the insurances to cover us there. So it's across the board. We, at the moment, to be frank, engineers in Perth are all flat out, and they're all so busy on projects. We've recently been sending work to an engineer in Queensland, because they can work around faster than most of our guys in Perth can, because everyone's just so busy. And we understand. It really is. Perth has been under the pump for 12 months now, and it's still pushing hard. I think we've got another year to go before any sort of settle down here.
Yeah, project industry starts to the heat's coming off a little bit in the project industry at the moment. Let's talk movement, please, David.
Yeah.
So I've had experience overseas, not so much in Perth, because 90% of the sites in the metro area are Class A sites. We had Class H up in the hills, so we get into clay up in the hills, and we did probably 5 or 6 years ago now. We did a house on stumps, and it was a steel structure, about 4 meters in the air, back to zero at the other end of the house. Quite a cambered site, looking out through a valley. Beautiful house, beautiful site. But over the course of the following 4 years after the build, the site, because it was on a hill, you had underground water, and those piles were concrete piles, drilled, Rio, and filled with concrete, and then casting plates on the top for the steel structure. Now, every winter the house moves, and we're all within tolerances. The engineer's been there and checked it, and everybody knows and is aware of what's going on. The house moves slightly every year, and it can move up to 10 mil on the structure. So between piles, there can be a movement of 10 mil with the groundwater moving the piles, and they're only moving up and down. They're not moving left or right or anything. They just move up and down with the volume of water in the clay. How does Surefoot fare with that?
Yeah, look, I can't answer to that question directly, but what I can say is that when you driving into clay, that obviously moves considerably depending on the moisture content. The clay will move around the Surefoot, and the Surefoot itself, the movement is negligible, if at all.
Yeah, I would have thought so, because it's 4 separate or 6 or 16 or whatever pile you're using, because it's 4 individual piles.
Yeah,
I would have thought the impact would have been far less.
yeah.
Whereas,
And also I would suspect that any expansion up would be uniform and therefore and minimal as well. From my discussion with engineers on this question, because we've done many projects, and a lot of sometimes we come to projects and we ask the engineer, we're not sure about it. You know, we think it needs a bit more thought to a project, and so we deal with those accordingly. One that comes to mind once again is Gogrup. The boardwalk at Gogrup is all on Surefoot.
yeah,
The whole thing is on.
that's in water. It's swamp.
In water. Yeah.
On a swamp.
Yeah,
So, but when we got further out in the boardwalk, the piles were going in a little easier than we would have liked. So then what that meant is we had to get a swage pile, and we just added a meter until it embedded itself into the bedrock or whatever, embedded or got enough resistance from driving the pile in that we knew it was firm and wasn't going to go anywhere. And then we teched it off. So we drove it in a lot further to help find that rigidity. So once again, if it was soft clay and you drove the pile in and it went nowhere in a second, that would be really concerning. So then you get another pile and you would keep driving them in until you found something, firm to attach to. But that's happened once in the last 5 years that I've been doing it. So,
yep. Okay, so let's have a little chat about your plates then. So if I can, one thing I love about the pile is the ability to locate the top plate and the column. So on the top of the plate, actually, I'll let you explain it. There's facility to move this thing quite a bit.
Oh yeah.
Yeah. So do you want to go through that and explain that to the audience, please?
Okay, so if you were going to a remote site and you wanted to iron out any chance of failure, what we have is the Surefoot. We would bolt the Surefoot to the ground with 4 140 mil bolts sticking upward through it, bolted to the Surefoot plate. We would then place height nuts down all the way down. And then we would place a 10 mil plate on top of those nuts. And then that 10 mil plate has cutouts on an XY axis. Now, then on top of that plate, we place I hope it's not confusing. We place.
So it's slotted holes. Essentially, it's slotted holes on the ball.
Yep.
So you've got directional movement on every axis for that plate.
Yeah. So what you do is we've got a bottom bracket that is has 2 sides to it to receive the SHS.
Yeah.
So then you bolt that bottom bracket into that XY axis, so you can move it left, right, north, south, east, west, anywhere you need to move it while that bolt is loose. Get it in exactly the right spot, tighten it up there, and then you place your SHS inside to that bottom bracket. That bottom bracket has walls that are about 150 mil tall.
Yep.
And then you either bolt it or take it off, but you've got your SHS in exactly the right spot. And that application would be, say, for example, you're in a site where you're installing the Surefoot, you're a novice, it's your first house and what have you, and you install the Surefoot and maybe you've pulled it off to the side by 10 or 20 mil. We try to iron that out by giving people all of our offcuts and giving them extra piles. So there's a sleeve in the center of the Surefoot, and I recommend everybody is if you're not doing it for the first time, you just place the Surefoot where you want it. you drive that sacrificial pile straight through that center, and that holds it exactly where you want it.
Yeah.
And then sometimes you can leave that pile sitting 150 mil out of the ground, so you can slide that Surefoot up to the height you need it,
Yep.
take it off at the height you need it, and then drive the piles in. But we like to place everything on the ground firmly as a rule.
Yeah. And we all know it works for termite treatment because
yes,
of steel.
Yes.
It's a ripper that way.
Yeah.
That was one of the things about the product that really caught my attention, was the amount of research and everything that's gone into it from day one seems to be extensive. So what you were saying earlier, Simon, about, trying to get stumps in the right spot, and when you're getting them in, the perfect spot for bearers and everything, so you have a halving joint you can screw onto your bearers. With this particular product, man, everything's thought of because it can move like that, and you're arriving wherever you're arriving, even if you're just building a deck or whatever it is. The fact that you have that movement, you can be 20, 30 mil out, even up to 50 mil from what I've read on the website. You can be 50 mil out and still hit it. 50 mil is a lot.
Oh yeah, get a stump 50 mil out, you're like a dummy.
Oh yeah, you're taking it out of the ground and going again.
yeah.
Just getting back to to Neil, the guy who invented the Surefoot. He, prior to this, he was installing cantilever carports in Melbourne, and he got sick in the winter having to dig holes in clay to pour concrete for these cantilever carports, and he thought to himself, "There's got to be a better way." So it was those cold winter Melbourne days digging holes in clay that actually created the Surefoot product, for sure.
I see you guys have done one in Karata. I saw it was a cantilever shade structure over the skate park.
Correct.
And there was nowhere to basically to put in concrete footings.
Correct.
It's an absolute ripper, so it is. Like, the cantilever on this thing is stupid. It must be over 6 meters.
Look, it's actually prior to my time, so I don't know. I don't know what the size of that project is. But it's a skate park, very tall. It would have to be 5 to 6 meters tall for sure, and then leaning out another, probably 3. But that's obviously been there for at least 6 years now through many cyclones. And that is on, from my memory,
there's 8 piles. Sorry, 8 piles in total.
Yeah, I think they're 8 piles, but and this is an important thing with Surefoot, is that those 8 piles are then joined together by a UB, and that is what that cantilever is sitting on. And it's the UB that spreads the moment load amongst those footings that allows that to be so strong. To give you an example, again, the biggest we've done so far is a 40-meter communication tower on Surefoot, and what we did there is we put 3 S600s. This is down at Jacket Up in the south of WA. We put 3 S600s down in a triangular pattern, and then on top of those we put 250 UBs, like a big triangular frame that was then bolted to the Surefoot. And then the 3 legs of the 40-meter tower then got bolted to the triangular frame of the UB. And that's how the load was transferred through to ensure that it could take that moment load of the tower.
Yeah, but a 40-meter tower, man. Can you
We did a
imagine the wind
40-meter
loading
tower.
on the top of that thing?
Sorry?
The wind loading on the top of that thing is ridiculous.
Yeah.
Yeah, look, I don't know how it works, to be honest. I look at it and go, it's a couple of pipes driven into the ground, like, seriously. But it works. It absolutely works.
I'll give you another example, Brian, is in a lot of projects that we've been to where the ground is fairly hard, and this is an indication of how hard the jackhammers work, is we drive the pile in, and by the time we've driven the pile into that clay or dense ground, it comes up through the sleeve of the pile. And we've got some samples in our office, and that mud, by the time it comes out the top of the pile, because of the compression and the heat that's generated by the driving, it's solid rock. I've got it on my desk. It just comes out of the pile. So the pile, it's full of the ground, and it's surrounded by it, so it's got skin friction on the outside. It's just part of the dirt. So that to me, it's just got nowhere to move. And we did a job out at Cunderdin when the ground was really hard, and I'll always remember this. We were standing because the company didn't believe the Surefoot could perform, so we drove it in with 1,500 millimeter piles out at Cunderdin, very, very hard ground. We got their forklift out. It was a 7.5 ton forklift, and the forklift couldn't pull it out of the ground at 7 ton. But what was happening is the Surefoot is 200 by 200 across, but the ground was moving probably for a diameter of about 2.5 meters across. You could feel the ground pulsing as we were all standing there, and that's when it really brought it home to me that the spread of those piles down in the ground really captures so much of that dirt that it really pulsed a large section of ground. So that really brought it home. And the only thing that broke was the tech screw that was supposed to take 2.2 ton in shear, but it broke at 4.6 ton.
Win-win. So let's talk. We're tight on time. Let's talk about how you're driving them in, please.
Yeah.
So we're not just going to Bunnings for a jackhammer, are we?
We are in some cases. Yep. Look, if depending on your job, I'll give you a good example of that. Is we did a project with the Children's Forest down in Rockingham, and it was all volunteers, and all the volunteers had retired. And so, but they had volunteered to build the boardwalk through the Children's Forest, and I was shocked when I turned up because, the age, I shouldn't be ageist, but I'm 60 myself, by the way, so I can't be too ageist. But and they had a little full bore from Bunnings and a little carry generator, and I was a bit shocked myself. But because it was the Children's Forest, it was very soft ground. It was all marshy and what have you. They had all the time in the world, and they got the job done just like that, and that amazed me. But obviously, if you're going on a job up north or in many other applications, you go for bang for your buck. So in our case, we use Hiltis. The Hilti T3000 is the best you can use. You can hire them at Kennards.
Yeah.
We supply the drivers because they will do in 2 minutes what a full bore jackhammer will do in 6-7 minutes. And that's so if you're on a job, that makes a big difference.
I see the guys in New Zealand using petrol ones.
Yeah,
they've got a little petrol engine on them.
Yeah,
they look ripper. Especially if you're regional, like.
Yeah, they're great. They're great, but only in softer ground. They're great. So so if you're dealing with very hard ground, they don't have the grunt to get where you need to get it. So that's what what they were really good for is from a safety thing. If you've got a tall pile, for example, a 2 meter pile, they're easy to place with two hands on top of that pile and drive down. So they're a good safety thing. And look, yes, once again, that'd be good if you had a little job and you're in soft ground and you know that no problem at all.
Yeah, just clay or whatever.
But if you wanted to do a house and you didn't want it to turn into a drama, you would go and hire a Hilti T3000. And if you're an amateur and you had 20 footings to do, you do them in a weekend.
Yeah, right. Okay. Well, Simon, you got anything else, Matt?
No, but I'm very interested in the Surefoots. We've got a project coming up, and yeah, there's risk of rock, and I'm just dreading. And we've got like 90 stumps spec'd for it.
Yeah,
you'd have far less in.
Yeah.
Far
so
less.
I suppose just the concern I have is Surefoot appropriate for rock and rock at depths of a meter. What would you say to that, David?
What rocks that are a meter deep?
So the geotech reports found that it's soft clay, it's not good clay, and then at between a meter and 1,200, typically there's basalt found.
Right. Okay.
So my concern is that there's going to be floaters at all different heights, like even there might be some at 400 mil and then some at 1,200. So that variable is going to be really painful no matter what footing system we go for.
Yeah.
And I suppose is Surefoot an appropriate footing system for
that application. Yeah, I'm with you.
yeah. Yep.
So what I'd say to you there is that if you've got a lot of footings to do and there's rocks here and there, firstly I'd find out what the rocks are. But if there's a lot of footings to do and it's clay, soft clay, that really is Surefoot's bread and butter. You would find that installation a lot easier with the Surefoot. And then when you came to certain footings where all of a sudden you're driving down and bang, say at 600 or 800, you hit rock that you just can't get through. If the other 3 piles are into full depth and most of the other footings around them are also installed, an engineer would then generally say, because he's got his safety margin built in, I can live with that. But if he says, no, I need that particular one because it's crucial to be in, and you've stopped at 600 and he wanted a 1200 depth for argument's sake, what we would do then is we cut the pile off flush with the top of the Surefoot. We get our 850 mil long drill bit, and then we drill through the center of the pile all the way down into that rock. If we need a bit more, we've got a 400 mil extension, and then we keep drilling into that rock, and then once again go back to clean that hole out, threaded rod, fill it with grout, all the way to the top of the Surefoot sleeve, and then that grout becomes a firm or epoxy, once again, filler, depending what the engineer specifies. And then that's job done as well. But what it has done, but the majority of the footings that you are going to hit rock, it's made your life so much easier than trying to dig holes in clay and fill them with concrete.
Yeah. And you would Surefoot have engineers in Melbourne that could assist in that spec up of that footing system?
100%. And Melbourne's our head office. That's where all they control everything there. So yeah, if you go to Melbourne office, they've got it all going on, and they've got 3 engineers sitting at a desk in the head office who could answer any of your questions. And as we do when customers come to us who are not sure about the Surefoot product, is we give them a rough idea of the costs and the pitfalls, and then you weigh up those against your alternatives, and generally as a rule of thumb, we come up trumps.
So email them and they'll provide that insight, and we can make an informed decision. Yeah,
absolutely.
Okay. I've got 2 more questions for you if you can hang around.
Yeah,
I know we're gone over an hour, but I don't care. I really want to get this information out of you. So the first one is with respect to engineers, right?
Yeah.
And this is no disrespect at all, but when it comes to installations in the field, are there any engineering inspections while that's happening, or are we relying on installers? So that's just for the general audience. I just need to know that.
Yes. No, we're relying on installers. So in the case of the jobs that we install, yes, our guys have to give us the pile depth, and they know that if all of a sudden a pile has stopped, and that happens regularly, and it hasn't gone in full depth and what have you, they know then to pick up the phone, give us a call. We ring engineer, because engineers certify everything we do. Now, when other companies buy footings from us and go and do their own installations with their own crew, once again, yes, we are relying on their installer to be truthful.
Yeah.
And he has to sign a document, a pile log, that has to be presented by their company, signed, and the installer has to be named, his signature, company name. It's purposely quite a involved document to make it look officious, so that it's important. And then that information then gets transferred to the engineer, and on the strength of that information, they get their certification. So they know that if things aren't right, and some customers say, oh, it was close enough, and we say, well, yeah, close enough is not good enough for an engineer. You're going to have to go back to site and do it properly, and we've had to tell that to some people. So but yeah, it's an engineer-driven process, unless you're putting a sea container to store your motorbikes on your farm. Then it's just 4 footings, throw them down. You've got nothing to worry about.
Yeah. So then, leading on from that, is this a performance solution?
Sorry?
Is it a performance solution when we come to getting our approvals with councils, etc.? Is it a performance solution, or is it's just a standard engineering drawing that goes in?
Yeah, just a standard engineering drawing that goes in. And just
Okay.
getting back to Simon's point about his 90 footings, because of the capacity of a Surefoot, you could, if you wanted to relook at that, increase the size of your beams and reduce the amount of footings actually required.
Yeah.
So I don't know what your structure is like, but Surefoot has great capacity. So quite often we'll see projects where we'll say, well, look, just increase the size of these beams, and instead of having 20 footings across there, you can have 12, and that makes a big difference to the cost of the footings and the initial overall anticipated cost with the 90 footings. So that's something worth speaking to possibly your engineer about, and saying to him, look, mate, this is the capacity of these things. Or once again, Simon, just go to Melbourne and they'll talk you through all this, and they'll tell you the best way to throw these questions at the engineers, and they'll guide you through it from there. They're pretty good like that.
Yep. No, I'll be emailing them after this, get some insight. That'd be good.
This is one of those light bulb products, isn't it?
Indeed, it is.
Okay, so David, with respect to the installation on site, one other thing I'd like to ask, as sitting in a builder's seat, if we're taking, like, let's say Simon hires you guys to do the installation and everything, who takes care of the survey and the location of the piles?
Basically, the customer does, or we do. If we're doing the installation, we've got a certain skill set where we'll look at a job and say, right, we want survey pegs in these 4 positions.
Okay.
And then from all the rest of them, we can measure off of those, and then we'll run from that. Some sites we go to, like we've gone to a few remote sites, where very difficult sites that we're going to, and it's where we ask the customer then to pin. To give you an example, this is a 50 or 60 meter long tunnel for haul packs. So we went to that project and we asked for every footing to be pinned, so we could just turn up to site, place the footings on the ground. We didn't want to have to be trying to work out for 50 or 60 meters, keep everything in line and what have you. So they gave us certain pins, but then when we go to projects, we'd like to think ahead. We make up templates. So we put bolt sets through all the plates prior to them leaving. We made up templates and bolted them to the plates, so we knew that our distances were perfect and all our bolts were in exactly the same spot. And we planned ahead like that. So, or if it's a simple job, like once again a sea container, or if you're doing your own house as an owner builder and you're handy with a tape measure 3, 4, 5 and a little laser, then you can kind of work it out, and if you can read a set of plans.
Yeah, as long as you've got your surveyor to mark your distances.
Yeah.
From boundaries, etc. Make sure your boundary setbacks. But with the Surefoot, like, everything's going on top, so there's plenty of movement there. Plenty of movement. Okay, so last question from me, unless you've got some, Simon. But I've got the question I ask everybody is, what's your challenges? What's your biggest challenges in the industry? And if you could make any changes in the industry, what would they be?
Challenges in the industry, the quality of the trades aren't given enough support and recognition. Government needs to put a lot more time into training young men properly into producing the goods. We should be getting them straight out of school over here and teaching them locally what to do. I see a lot of poor workmanship around town. I see a lot of guys using grinders with no glasses on site, and that is hard to fathom that anyone would be that stupid in this day and age, and hard to fathom with sites that I go on where supervisors are wandering around, but that happens. So I think regulation to a certain degree is lacking, and quality control in our industry is lacking, and we'll end up with buildings like mascot towers in Sydney. It's already happening in Sydney from poor workmanship, shit materials that were brought in from China and weren't inspected. Take you back to Grenfell Tower in London. And nothing's really stopping that happening to this very day. The hospitals in Perth, Princess Margaret, had similar issues, but we're still carrying on, and there's still builders in this town building mediocrity, and when we're paying $1 million for this mediocrity, we're just not getting the regulation that we need to ensure that the quality is there. And that's we're a first world country. We should have first world qualities and accept nothing less. And Perth does things very well. And I just think we've dropped the ball on that one a little bit. We're not enough apprenticeships.
Yeah, absolutely.
Right on.
I second that. Can't agree with you anymore.
Mhm.
Right, we got some quick fire questions.
Okay.
Who's the most famous person in your phone book?
You now.
Yeah, thanks very much. Favorite sporting team?
Favorite sporting team? Look, I don't really have one anymore, but I enjoy the Ashes when they come around. I watch that religiously, and I love every minute of it. But after that, the rest of it, I turn off to.
Right. Passive house or passive solar design?
Well, look, what's my understanding of passive house is limited. What's your explain it? Is it the lack of airflow? Would that capture it in a word?
No, oh, don't say that, please. Oh, goodness
There we
me.
go. You tell me.
We don't have it. Go back and look at our webinar. That will explain it in depth.
Okay.
Yeah, absolutely. I'm going to put you down as passive solar design. I reckon
That's where I'd be.
I reckon you're a windows open kind of guy. You like the heat. You like the sun. I reckon you're a passive
Well, no,
solar.
it's more about innovative things. Like years ago, I learned of the Trom wall. Have you know of a Trom wall?
No.
I've heard of it. I can't.
Okay,
yeah,
so imagine.
refresh us.
Okay, so imagine, I'll use Western Australia. Imagine in the wintertime when it's cold and miserable, but the sun is in the north. If the north-facing aspect of your house, you had a thermal mass tilt panel concrete wall and painted it black, all day the winter sun would be heating up that Trom wall for you and transferring that heat into your house. So something as simple as that to heat your house in the wintertime. So your living area could be kept warm by a tilt panel wall that's got the winter sun all afternoon. So the little things like that to me are there's a million innovative things and we should be exploring them more. I think there's lots of different things out there.
My only comment to that is to every action, there is an equal and opposite reaction.
Yeah. Roller shutter over it in the times that you don't want the heat. And then you get no heat.
Roller shutter over a tilt panel
That's
wall.
passive
facing
solar
north.
design.
Come on.
Or an eave over it.
David, you were doing so well up to that.
It's only 3 meters tall. It's only 3 meters tall. So, but free heat and free cooling. That's the future, isn't it?
Yeah, I'm going to have to disagree with that one wholeheartedly. Absolutely. Tilt panels should not be used in a home. Do not use them unless they're inside for an aesthetic feature. That's my
thermal
opinion.
mass. Let's say thermal mass.
Yeah, thermal mass.
Yeah,
Okay.
yeah. What about Nirvana panel? Are you aware of Nirvana panel?
Let's move on from that one. We're gone over time. Timber or brick construction? I think you've already answered that.
Oh, double brick, worst thing in the world. We shouldn't build houses out of double brick. I live in one.
Yeah, same as that. Rubbish. Favorite music?
Every there, 40s to the 80s.
Yeah, right. And Tim Tam or Anzac?
Tim Tam.
God damn. Wow. What a great conversation. It's an incredible product, David, an absolutely incredible product. Thank you so much for coming to join us today. And we wish you luck in the future with it. I know you probably don't need that. This thing is going to go worldwide without a doubt. It's a truly innovative product and it's leading the way in residential industry, particularly with sustainability and pre-manufactured construction, prefabrication. It is the future without a doubt. Thank you so much for joining us.
Thanks again, Brian. Nice to meet both yourself and Simon. I'll talk to you down the track.
Yeah,
Thank you, David. Excellent.
Thanks, guys. See you then.
All right. Once again, folks out there, don't forget to check out dsba.com.au on the website. We've got all our information there. As always, there's webinars floating around. The last one was an absolute ripper on Passive House. The next one's going to be even better. All of our podcasts are also on the website. You can catch them on what's the name of that platform again, Simon? For me, that's the dinosaur.
U-Box.
No, not YouTube. Where's our podcasts?
Where is it? Apple Podcast, Spotify Podcast.
Spotify, that's the one.
Wherever you get your podcast.
Yeah, wherever you get it. Yeah.
And be sure to subscribe and give us a rating as long as it's 5 out of 5.
Nothing less. Okay, thank you so much, folks, for joining us, and we'll see you on the next one. Thanks, Simon.
Cheers, Brian.
All the best, folks.